All right, class. Hey, I've got a jar full of money here, and we're going to say that this money is the make-believe element My. So My, right? I couldn't call it coin element because CO is taken by cobalt. And after examination of the periodic table, I also found Cn is also taken. That's Capernacium, the element 112. I didn't even know that. I had to look that up. It's a very large element that we don't deal with, most likely radioactive. So not a common one to deal with in chemistry, but we can't use either of those. So this is element My. Okay, the jar represents planet Earth, and if we wanted to say learn something about how what isotopes comprise this element, then we would need to sample, because we can't collect all of a certain element on Earth. In real life, we can't collect all the oxygen. That would involve collecting it out of the air and out of the water in the oceans, and it's not feasible for us to do that. Same thing if we wanted to try even iron, right? You think you could dig up all the iron in the world. You'd also be extracting all the blood from humans and creatures because, right, hemoglobin is what carries, it contains iron, and it's what carries oxygen through our body. So if you want to get all the iron, you'd be having a hard time to do that. So anyways, we're going to sample, and I'm going to take a sample of this money element, and we're going to analyze the types of isotopes that are prevalent. So here you go. I'm going to grab a sample. I do want to make sure I've got a nice mix, so this will work. Okay, so here you go. I'm going to sort my isotopes from heaviest, and by heaviest I don't mean most valuable, I mean the ones that are the most massive. So here's all my quarters. Got a lot of quarters. Oh, this is interesting. I've got equal percentages of nickels, pennies, and dimes. All right, so that goes from heaviest to lightest, and I have 4 isotopes, right? So isotopes are just different versions of the same element. These are all money elements, okay? But this one is the heaviest, and this one is the lightest. So if you guys want to know, let's just quickly figure out some percentages here. So I will count these out for you. We can find their percent abundances and their average atomic mass. Okay, so I'll do stacks of 5. 5, 10, 15, 16, 17, 18. All right, I have 18 quarters. Just so we can get an average on their mass, or I'll just give you the mass of one. We're going to assume that these all weigh the same, because isotopes, really, if we were dealing with true protons, neutrons, and electrons, these isotopes would be equal in mass. We do know that these quarters are all a little different, but let's assume that all 18 quarters weigh, what is that? 5.73 grams, okay? 5.73 grams. We have 2 nickels, right? So we'll say that this isotope weighs 5.0 grams. We've got 2 pennies. This penny weighs 2.52 grams. Okay, even though we do know some pennies are heavier than others, especially the older ones, which are made out of copper. Ooh, just to show you, ignore this number. But yeah, that penny is heavier. Okay, so the original penny we said was 2.52. Let's just assume that they're both 2.52. And then we have 2 dimes, and each dime weighs 2.26, so 2.26 grams. So knowing that, you've got 18, 2, 2, and 2. That's 18 plus 6. That's 24. You have 24 coins, or 24 monies, atoms. And can you calculate the percent abundance of each isotope? And then can you calculate the relative atomic mass, which would be the weighted average of all these? Okay, so if I was to take this whole sample and find the average mass of those items, then that would be the relative atomic mass. So again, 18, 2, 2, and 2, with the masses shown 4 isotopes, calculate percent abundance, and then calculate the relative atomic mass. Now, that's what scientists did, and they do that, say, in different sites around the world. They get a representative statistical sample set, and then once they're certain on their relative atomic mass of an element, then they publish it on the periodic table. So those values that you see, and I'll walk you over and we can take a look. The values that you see for these atomic masses, here's Copernicium, okay? Ooh, that one's kind of funny. They say 285 because they don't know enough about its isotopes, because again, most of these are man-made down here. So let's go to a more common one, like let's go to cobalt. Ooh, so cobalt has a average atomic mass of 58.93 atomic mass units, right? And so that value is calculated just like you guys were doing with your money element. Okay, so hopefully that helps. Get those answers in. I'll have a little area in a quiz for you to type in those results, and then some more questions. But that's how isotopes and relative atomic mass seem to work on the periodic table.